से मोटा है इसको अच्छा माने चल देख इधर आ So, good evening, everyone. This is our last meetup, and uh, then I think the exams. So, well, this week 11, right? Week 12, yes. So, okay, let's start. So, a little bit of reinforcement learning and little bit of comparing the generalization error and the we call that uh, I'm getting the name empirical error. So, a simple enough question here. So, are you able to hear me? Screen is not visible. Acha, not presented. So, simple enough question. You have been and standard reinforcement learning you need. State and action are there. Note that your system does not have access to previous states. So, so state will be like when a car is being driven, you see. So it is usually not accelerating. Okay. So that is why the state is the current steering wheel position, pedal position, and speed. Okay. And action is a physical action. Okay. So turn the wheel, press pedal. Others like change direction, change speed are not physical action. Okay. Those are the effect after the action. Okay. Easy enough. Any doubt? Now our old question here, like which classifiers does not require any modification so that we can use for more than two classes. So we know our linear classifier for only two classes SVM also just extension of the linear classifier having maximum margin. Okay, and the left two options are decision trees and k nearest neighbors. In k nearest neighbor we check the neighbor from many classes. Okay, and in decision trees you can have many branches. Okay, So, like, how many people are doing PhD here? Uh, it's quite a few, right? Like, which field you are doing? We can discuss. Hello, in which field you are doing your PhD? Hello, am I audible? Like, can anybody answer that?
Yes, you are audible.
Yes. So, like, I was asking, like, which people here are currently doing a PhD and which field? Nobody
So
can.
I'm not doing PhD.
Huh?
I'm not doing PhD.
Acha, acha. Means like others. I think quite a few are here actually doing like Prashant.
Sir, I'm doing it on the diabetic retinopathy using deep learning.
Acha. Diabetic retinopathy with
Using deep learning approach.
acha deep learning approach. Acha. So in this course we have not covered deep learning.
Yeah, I have joined deep learning also. So before that, I wanted to learn machine learning as well.
Acha, acha, acha. Acha, good idea. Yes, you need the background. Deep learning is mostly like going deeper into the neural networks. Okay, having many layers of neural network that results in a deep network, and using in different cases like vision and language is deep learning. Okay, so like how are you planning to do like so diabetic retinopathy detection? Acha, so that is like CNN, some CNN what, right? Object detection.
Yes, yes.
Acha, acha. Okay, so object detection, right? Okay, so okay, let's progress. Uh, Arijit, you are also doing a PhD, I think. No,
Hello?
you are also doing a PhD.
No, no, I done my PhD 3 years back.
Acha, PhD already done. Acha, nice.
I'm the assistant professor in Githam University,
With acha, let me
Hyderabad.
uh, one minute. Just reduce the fan. Actually, harder to hear. You were saying?
I done my PhD in 2020, and now I'm currently working as a assistant professor in Githam University, Hyderabad.
Oh, nice, nice, very nice. Okay, Priya, your name has a PhD here. Yes. So, what are you doing PhD in? Just wants to join. Priya, can you hear me? Like, okay, we can progress actually. If you want to say your area, focus area, network connection problem. Shit. Actually, my network got off. Actually, network error. So, net, I was having network issues. You are also having. So, like as I was asking, like which field? Can you hear now? Yes. So, like which field you are doing your PhD?
Sir, I'm doing PhD in advanced deep learning, sir.
Advanced deep learning. So, what do you mean by
Basically,
advanced?
my research is in sign language.
Sign language. Acha.
Uh,
So, like what you're doing, trying to do, detect sign language?
no, sir. It's already there, na? That is not. Basically, we are working for deep and dumb fellows. Basically, working for a model.
Working for a
Model.
model means? Which
So that I don't want to tell here. Actually, that is a basically my work in is in deep learning
Acha.
concept, but basically it's a CNN model only.
Acha.
Deep concept, I don't want to say.
So CNN model to do what? What is the purpose?
Basically, the purpose is we are going to create one unique tool which can be helpful for the deep fellows only.
Acha. Okay.
Yeah.
Okay.
Yes.
Nice. So, like as I was explaining, so this is our old question. Nothing very surprising in here. Like which type of classifier can be used naturally for more than two classes without any modification? So decision trees and k nearest neighbors, which you have studied, you have seen that more than one classes are usually used automatically. But in linear classifier, there are only two classes. Okay, in support vector machine, it is the extension of linear classifier in which we are looking for maximum margin. Okay, so there you need something by modification to change into multi-class problem. Okay, and another very easy question actually. Means nobody needs to know anything to do this question. So as you finish the task, you should be given a very high reward. Okay, and a negative reward for negative reinforcement for uh, means like time you're wasting to get to the finish line. Okay, like that. You cannot give +1 for going off the road. Going off the road is the wrong thing. Okay. Uh, don't know why. And minus for going off the road can be there, but
Sir, could you please zoom a bit, sir?
huh? Could you?
A little bit zoom it, sir. That screen
Acha, zoom.
is not that much clear. Yeah.
Acha. Well, okay. So design slideshow. Acha.
Yeah. Okay. Now.
Um. So this is the best possible actually, but mm, question part A could have been also. I mean, going off the road is a bad enough thing to do. But I think you have to accept the best possible one. So another question. easy one as well. So RL game is there, RL agent is there, and like two players like chess or go, and what is the best way to train the model? Uh, so the thing is like with against human players, like there's a lot of hassles as you see, like you have to call many players, different levels. Okay, some beginners, some medium, some advanced, some expert level. Okay, so that is the hassle with it. Okay, possible, and also but what happens that you have to train on many of those humans. Okay, so that's another problem. Ritika says C. Hmm. C will not be the answer here. Which question you are answering? Uh, yes, B is the answer actually. So so what we are doing is like being smart here. Okay, and so what we are doing is suppose we're making two versions. Okay, and suppose one is more knowledgeable, but just to say that it has been trained on one human. Okay, and training one of the moments, letting one our agent to play with another. Okay, so both knows. Okay, now take the better ones and make the weaker ones play against it. Okay, like that, continue making it happen, and it keeps performing better and better. Okay, you need some humans in this case as well, not written as such, to learn the initial moves actually. uh, okay, and you cannot create a supervised agent actually on the best humans. Okay, because the supervised model only can predict actually, don't know which actions to take, which result into a better action. Okay, unsupervised also will not work here. So the question is, empirical error is always greater than generalization error. So that is actually wrong. Generalization error is the error on the unknown data set or test data set. Okay, and it is usually greater than the training error, error on the training data set, which is the empirical error they've said. Okay, so that is why it is wrong. Okay, and training data and test data have different underlying true distributions. They usually have same or similar data distribution, because if the model, if it trained on one distribution, needs to predict on a similar distribution to be correct. Okay, maybe I should write something actually, moving too fast maybe. Okay, so as I was explaining, generalization error is defined as the performance over a unknown distribution, suppose probability distribution P. Okay, okay, but okay, from this we are getting data. and that has been used to estimate this correct or not. Is that this is making the correct prediction? Okay, so this is how we do it. Okay, generalization error. Okay, so from this unknown distribution, new distribution, you can see we're getting this data, and we have used it here. Okay, to estimate this error. Okay, now empirical error is like on the training data, how many cases. Okay, summation over 1 for hxi. These two things I have actually taught you in first lecture or something. Okay, this is the empirical error training on the training data. Okay, it is usually lower than the generalization error. Okay, and they cannot have a very different true distribution, because then the model will not be able to predict. Okay, so they cannot have different one, or same or similar or very close type. Okay, this is what is needed.
So what is the answer of that?
Achha. Okay, so actually
Which of
both are false here. This is maybe a little difficult question. So this is the Chernoff-Hofding bound for classifier H, as you can see. Okay, and this is the, as you can see, so here the E of H is the generalization error. Okay, okay, and this is the empirical error. Okay, so what you're saying is that error between them is greater than some value. Okay, suppose 10 to the power minus 3 here. So I need difference between them. Okay, suppose is greater than 10 to the power minus 3. Okay, and usually a small number. Okay, okay, uh, and so you'll be putting this value here. Okay, and 2 e to the power minus 2, this square 10 to the power minus 6. Okay, m. Now if you have to understand that you need a m of significantly large value compared to 10 to the minus 6. Okay, to get a meaningful bound. What I mean by that is, like, if m is like close, suppose like 100, 200, 1000, what will happen that this is like close to its power is close to 0, so the bound becomes close to 1. So any probability is less than 1, we get no information from that. Okay, bound has to be tighter. Okay, very means the tighter it is, that it is
so screen?
it is small. Oh, What problem? What a problem. So, like network problem, as you see, um, can do anything about that actually. Uh, so, from where you could not hear, question number 2 done. Question number 2 done. Acha, hello. Network problem actually. Can do anything about it. Able to hear now? Audible?
Yes, sir.
Okay. So, which question number 2 you have heard to the end? Any answer? So I had started question number 3 here. Question number 2. Acha, he's saying C and D. So question number 2 have understood or acha, screen is not visible. Acha, oh God. Everything goes to default when the network is cut. Okay, as I was saying, like question number 2, you've got it. Question number 2, you've got it. Some answer. Okay, I think you've got it. So let's move on. So as I was explaining, suppose gamma is 10 to the power minus 3. This eta h is the generalization error, and eta cap h is empirical error. Okay, so that the difference is at least 10 to the power minus 3. Okay, between them. Okay, nice. So what is the probability such that the difference is greater than 10 to the power?
Sir, make it presentation view.
Acha, then I will not be able to write. So there's a problem. Okay, let's see. So so that is how we have to do it. Okay, so this is I've just put the value of gamma here. Okay, so what I was explaining is that you need a significantly large value of m such that the bound is meaningful. What I mean by that is, if m is small, suppose 100 or 1000, what will happen is that the power is a large. Power is like close to zero, as you see. Okay, so what will happen then, the bound is close to 1. Okay, so any probabilities like that is close to 1 is not meaningful. Okay, bound has to be tighter. Okay, and less than 1, significantly, some significant value it has to be. Okay, and for that the m has to be large enough. Okay, now what is happening is that uh, as we are increasing the number of samples, the uh, we are putting this formula. Okay, and does not give more accurate estimate. Okay, so what do you mean by that is that uh, as m increases, the bound should get tighter and more meaningful. Okay, um, so okay, you can understand that if the bound number of training examples increases, what will happen that it will become larger and larger, a negative number on the power. Okay, so what it would mean is the smaller and smaller number positively, means the total number will be smaller and smaller positive number. Okay, um, so what would mean is that tighter and tighter bound. Okay, uh, so you have to understand that in okay, so what is happening is that these two, generalization and empirical error, should not be a large number. Okay, means the difference should not be a large number and should not occur for uh, should not give a should not be there should not be a high probability of their occurrence of their difference being large than our this what you can call is like a threshold. Should not be, means the probability of occurrence of a larger difference should be less. Okay, so okay, so this probability should be actually low. So what they mean by the number of samples as we're increasing does not give more accurate estimate. Okay, so what does it mean is this probability is bound is not getting tighter. Okay, got it? So what you can do about it actually? So the thing is that uh, like gamma is unsuitable. Okay, so this is the first example. Okay, let me bring some water. Okay, and then we'll discuss. Hmm. Okay. So idea is you have to understand is that so if you take a suppose gamma can be a large value or a small value. Okay, that is the distinction. Suitability, as you say. So what happens if it is a suppose large value? If the difference is large, okay. So what can happen is that so this gamma square will be also larger, okay, okay. So what it would mean is that means like my this threshold, okay, threshold is what you can say is higher, okay, or maybe loose, like that, okay. Means that I'm quite giving freedom that this can be different, these two, generalization error and the empirical error can be different, okay. So in this case what will happen is that this 10 to the power minus 2 will be a lot less, okay, and small number of m's, okay, would give the our tighter bound, okay. But you can understand that this will still work, means like there is no unsuitability problem. Means like in more practical case gamma will be less, but suppose it is a large value, then just we need small number of m, okay. So the problem cannot be gamma, okay. Any issue? Any issue here?
Sir, the fourth option says that samples are not from IID. So, what is IID? I didn't understand the concept of IID even in the videos.
Okay, nice question. Let's see. So IID is like independent, okay. Uh, Not in the mood to write, okay. Independent and identically distributed, okay. So it means that the samples that you have taken for calculating the empirical error, okay, they are independent. What means that each samples is not dependent on another sample, okay. And to understand the identical part, let's do a Google search. So independent, you understood that they are not dependent on each other, okay. And in probability dependent means like occurrence of one, means like occurrence of both. Let me write it down. Occurrence of suppose xi x1 union intersection x uh, acha, acha, 1 minute. x1 union x2 एक मिनट just got it wrong actually.
Hello. So can I speak one thing?
Okay.
Can you tell us about the pattern and is programming question will come on exam or not?
Well, I'm not sure mostly, but should not come exam as
Because
okay.
because in coding question, how we are able to run it? Because we don't have Jupyter and all. They're optional.
Where you'll have the exam?
In here only, is question varies from each center to center like that also? Hyderabad only.
Acha, Hyderabad. Means in center, most probably not actually. But coding may be difficult, right? Because in you do Google search for coding, right? Acha, that's true actually.
And the question will come from is the label of question is too difficult as the people are not able to pass like that. If one have follow the content and the assignment, is it enough?
Well,
The review is
okay.
there that people are not able to pass that.
Not sure actually. Well, I've never given the exam.
So, is the question comes from content and assignments or
Should come
something
from
else?
there actually. But let's see, maybe something here. Uh, the previous one, I think.
So previous year are not disclosed yet anywhere, right?
Cannot seem to find that. Review assignments.
Hmm.
Uh,
So it's the last time, so please give some tips and all. As
well,
after 1 week, there is exam.
I've never given the exam actually. How would I know actually?
You haven't given. So you have idea, no? Professor is with you only, no? So who is going to set the paper? You guys, you are doing PhD under him only, no?
No, not under him.
Okay, you're not doing.
No. Actually, I have no idea.
Okay.
Yes. What can I do?
Okay. Thanks so much.
Sir, even in week 11, few I think question number just a minute, I'll check. The question number 5 and 6, you were asked to run it on the GMM. I mean, when we are trying to run this, I mean, for both the questions, I mean, output is wrong.
Acha. Okay, so what are you going to do about it? GMM, right?
Yes, question number 5 and 6, using the SK Learn implementation for GMM model. When we run with the codes, the what we get, the options are not with what the answers are there. So,
That's a problem, right?
yes.
Fine. So I should verify with other classmates. So you're getting option matching as you're coding or different? Prashant, Arijit, Someone, Ritika.
Even I run sir code on Jupyter Notebook, I got the different outputs.
Different outputs. It must be wrong, really. You can show someone show the code, okay? Just before that, I should explain the IIT part, okay? Uh, so, so the occurrence of both the uh, this examples is independent of each other, which satisfies this, okay? So this is independent and identically distributed. What the mean is that from the same distribution, okay? Okay, you can see here as well. So means that there are no overall trend. The distribution does not fluctuate, and all items are taken from the same probability distribution. Okay, independent samples are independent. In other words, they don't contain everyone knowledge of one variable. Means you can see. Okay, very easy. Okay, uh, as you can understand that the identically distributed from the same distribution. Okay, and independent. Okay, independent means that occurrence of one does not impact the occurrence of other. Also should cover this question fully, okay? And so let's focus on this one only. Samples are not IIT. What happens is that means it can happen that as I'm saying, like increase the number of samples and this should give a tighter bound. But if they are suppose interrelated somehow, okay, and suppose occurrence both are not occurring together, okay, and or maybe both are occurring but should occur separately, will give drastic actually change in the bound, okay, or as you can see it may not reduce progressively as the number of trainings examples are increased, okay. And another is the choice of a hypothesis is wrong. As you can see, if you choose a wrong hypothesis, okay, which results in wrong prediction, okay, so then what will happen is that uh, this what will happen is this error is like error in both cases might be large, okay, and they might fluctuate, okay, even on increasing the distribution, increasing the number of training examples, the error means the test or training means like the what do you say generalization and empirical error might be very different in even on increasing number of it might not reduce, okay. So that is the situation. It is unpredictable case, okay. So this can be the answer. This is the answer. The mean is not from Bernoulli distribution. So you have to understand like what happens is that in this case what you're saying is that if the in the case of a classifier, right? So in the if not from a Bernoulli distribution, what happens is that any other distribution, okay. So uh, this one, let's see. So as you see, they have defined each occurrence, okay, has to be added, okay. This like indicator one, okay, and hi x, okay, xj plus not plus not equals to yj, okay. So I've taken a hi hypothesis, okay, ith hypothesis in the sequence I have of hypotheses, and J is the training example. Okay, so this is the Zi. Okay, and Bernoulli distribution, if it is not, okay, let's see, let's understand. So in our derivation, I think Bernoulli is considered, right? Mm, Bernoulli distribution, if it is not a Bernoulli distribution. So Bernoulli distribution is like this, right? Hx to the power yi, and okay. So this is our Bernoulli distribution case. Okay, this our so this is the probability of occurrence. So h of x is probability of occurrence of 1. Okay, so probability. This is the probability of occurrence of 0. It is not Bernoulli. I'm not sure about this one actually. Anybody know about this option? Like why? Why not? Or why? Anybody has this cleared? Why it can be Ajay? Do you have any idea? The distribution. If it is any other distribution, not sure really. Let's see if we find something here. So this is the our derivation was on Bernoulli only. The answer is not Bernoulli, I think. It's the Chebyshev inequality, okay, and Markov inequality. So from this, they coin toss example. Everything is on Bernoulli distribution. How can it occur without Bernoulli? Answer is not given as Bernoulli. Means it can work without being from Bernoulli as well. I'm getting the reason actually. Maybe wrong actually. It has to be Bernoulli. That's what I think. Acha, Chernoff bound can be applied to more general setting than that of Bernoulli variables. Particularly the following version of the bound applies to bounded random variable regardless of the distribution. So they have got this one, okay? Like difference is this gamma, as you can see, okay? And okay, so they have given like this, okay? So general situation is also there, but b minus a x is between b minus a. Acha, in our case it is 0 and 1, right? Acha. So has to be divided by b minus a, that is the range of each sample. Okay. But it should still come down, right? I think that is the idea. Yeah. Means with this formula, means like if you are not using Bernoulli, then the bound will be wrong, okay? But the bound should get tighter, okay? And that is why it's not the answer. But this cannot be used for any other distribution than Bernoulli. It is for Bernoulli. In case of non-Bernoulli, what will happen is that it is the difference between, comes like the difference between the range b minus a square, okay, b minus a square. Got it? Then it is the general case, okay. In our case b is 1, okay, and a is 0. Then you can see this is the formulation we get. Okay, not very convincing question actually, but let's come back to your problem actually. So if you can show what your coding error is. Sklearn find the correct option with the highest likelihood. So you're getting correct option, right?
Yes, sir. Yes.
You think Ajay is getting the correct option better?
I am giving the code.
Hello? You are?
I am giving the code.
Ajay, you're sharing the code.
Okay. Thank you, please.
Ajay, code also.
Is it visible?
Yes. She has formed an array and then put it into the pretend model, and mixture coefficient is equals to GM weights. Acha. So you can see. So this one is a easier question actually. So this is the union bound. Just adding all these, okay. Just very easy. What you have to do is 2 to the power minus 1 plus 2 to the power minus 2, like that, 2 to the power minus 5. I have to add this one, so what will be 2 to the power minus 1, okay, divided by 1 minus 2 to the power minus 1, 1 minus 2 to the power, what is the formula here? Forgot actually. R to the power n, 2 to the power minus 1, number of terms is 5, okay, to the 5. This should be the answer. Now question number 5. So like is reinforcement learning a type of unsupervised learning? It is not, right? And the B option is correct, okay. So that is like D answer. Policy is a mapping from states to action, okay. And then this one, like, formula is 1 minus k, then e to the power minus 2 gamma square into m, okay. This is the formula. This is the answer you get, okay. 10 to the power minus 2 10 to the power 6 becomes 10 to the power 4 here. K is 200 here. Now k is 100, but 2k is there, okay. So that one and 1 minus, okay. Nice. So very easy for you guys, I think. Okay, any doubt? Maybe let's see which questions you are facing this time.
Sir, how to find VC dimension?
Acha, okay, good question. VC dimension question is here, yeah. VC dimension of a pair of square. Okay, so the VC dimension is what? Is the suppose like you have the example that was given actually in the lectures as well, like the maximum number of points up to which a straight line can shatter, or means can classify any combination of plus minus plus. Okay, so 7. Question number 7. What to see here? Let's see. But like getting on VC dimension. Uh, and uh, uh, what was that? SVM. Acha, acha, got it. Cannot share it, right? Got the PDF. How can I send the PDF? Maybe a Google Drive link. So details on VC dimension. Okay, everyone learns VC dimension from this tutorial that I'm going to share. You can read from here, okay? Details on VC dimension. Everyone learns from this one only. Okay. But other than that, VC dimension is like suppose the linear classifier is there, okay? And in how many maximum combination of points it can shatter, okay? That is the VC dimension. So in the case of pair of square, you can understand maximum how many points it can shatter, okay? Or you can say it divides. That much is already necessary, okay? So just imagine a pair of square you have, okay? And you have to separate 3 points, 4 points, 5 points, 6 points, okay? That is the question. You have to think a little bit. Okay, for the rest of the question, follow a simplistic game and see how this is our so you're starting from here, okay? taking steps. Okay. At the start of the game, the agent is in start state and can choose to move left or right, which is right, and it wins. Acha, which because you love math so much, instead of saying the agent wins or minus, we still define a variable that will store its value. The value, acha, we give the mapping from state to its value. Initially, VLE is -1. Acha, the states are 0. Okay. Acha, for each state given, um, SL being the state to its immediate left, SR being the immediate right. Acha. VS is equals to 0.9 maximum of. Acha. Acha, got it. Okay.
Sir, I have doubt in the question number 8. What is Vx1 after V converges?
After
It
V
means
converges, what does it means? That is, it wins. Okay. What else can be?
sorry, sir.
After it wins, actually.
Okay. The remaining part I will solve correctly, but I
Right.
had some
Not very
doubt in
hard question. You
conversion.
have to use this formula and update the VS.
Simple है.
Ah.
It's a simple. Also, I have some doubt after V converges means win the game.
Hmm. Okay.
Sir, can you explain this question? I didn't understand.
You have to use this expression as you see. So SL is the immediate left. Okay. That you are here. Suppose you are at start. Okay. And so SL is here x2 and S and SR is the this
X3.
x3. Yes. And now what you're doing is that
Immediate right.
So you're moving from left to right. Okay. And
Initial conditions given 0. So SL is also 0 and VSR is also 0. So maximum of 0 is 0. Like that. So we have to consider.
Okay. And now you move. Okay.
So everything here is value is 0 then. X3, X4, everything will be 0. X2 and X3.
Okay, let me see.
Okay, X2 and X3 both are 0.
All are giving 0. X1 and X2 also they give 0. In the equation it required X3 and X4. Sorry, X2 and X3.
Let me see.
So what does it mean by VLE -1 and VRE +1?
Means like this is the, as you can see, the state to its value. Means this state has the value -1 actually. Lose 1.
Suppose
So it is not.
Suppose it is at a particular time at x1.
Okay.
So left VSL will be -1 and VSR will be 0.
Yes.
Initially. So -1 or -0 maximum is 0. Multiplied by 0.9, 0.
0. Yes.
So it's the condition or value of the particular state is given.
Okay. So keep trying actually. Means like what will happen is that it will move. Okay. One step right. Okay. And then again C. Then one step right again C. Okay, like that. Okay. Okay, what will happen if V converges? Okay, so this will be something positive x4, Vx4. Okay, then come left. Okay, Vx3 will be something positive. Start. Okay, x2, then x1. Okay, keep moving like that. Okay, and see what happens. What value you get. Okay, clear there. Means the game actually start means like the V value will change from here from x4. Okay, when you're standing at x4. Okay, before that everything will be 0, and left and right are always is increasing, minus and plus. Acha, acha. Sorry, actually I got this one wrong. Actually, converges here will be like the you got a stable value here. Actually. Okay, somewhat stable or close to stable. Okay, that is what is convergence. Okay, that will be the one. That is what the mean here.
So for this condition, the x at x Vx1 always will be 0.
Vx1 will not be 0. Let's see. Just see. Maybe I can take the picture here. And let's try a little bit. Let me show you. Okay, and so let me show you. So what will happen is that so you're here, okay, initial state, and what will happen is that as you move here, okay, and you calculate, everything will still 0. Okay, now you come here, okay, and you calculate the value of this state. Okay, so what will be 0, 1, maximum is 1, 0.9.
0.9.
Then you come here, okay.
Repeat again.
Means you're moving forward, okay.
How you get 0.9? How you get 0.9?
Means like you are here, you are standing here, okay, and you calculate the value of Vx4, that will be 0.9 times Vx3, maximum of Vx3, and VRE. Okay, so VRE is the maximum one, 1, and in multiplied 0.9 is 0.9. Okay, then you come back and you are standing here, and you see this is 0, and this maximum is 0.9, so 0.81 is the answer. Okay, now you're coming back again. Okay, you see, so what will be here? 0.7
0.729.
Yes. Now again here, okay. So what they have asked here first is Vx4, right? So Vx4 is 0.9, right?
0.9.
Okay. Vx1 is, let's see, one application of the formula. Vx1
It is 0.
Vx1 will be 0 actually, because for one application, first application will be 0 actually, and now you have applied many times actually. So this is applied 3 times actually, and now so what we can get here is actually this 0.9, 0.81, 0.729, so 0.9 to the power something, right? Number of steps taken. Now this will be 0.9 to the power 4, 0.9 to the power 5, okay, like that. And conversion, uh, conversions at Vx1 after V converges. After V converges. This is something to be seen actually. In convergence, what will happen is that it will become 0 actually. Let's see, in reinforcement learning, you can get something. Uh, case of our normal machine learning model, what is happening? Like in what we do mean by convergence is like uh, our model is converged means it is stable, okay, and the losses does not increase while training or does not decrease as well. Quite close, okay. Uh, sure. Let's try to understand. So we will here try to calculate the error somehow. Actually, let's maybe I was wrong actually. 0. You can write it at 0.9 to the power 3 or 0.9 to the power 4. Yes, I think I was wrong. This has a conversion to the power 4 and this is 0. As you can see, 0.9 to the power 5.
So it comes out 0.59.
0.5 to the power 0.9 to the power 5, okay.
0.9 to the power 5 is equal to 0.59. But this option is not given in the.
No. Somewhat stable value actually. And this is so again calculating this means I will go back actually, go to x2 actually. So this will be maximum of these, okay, so that is 0.9 to the power 3, right? Maximum 0.9 to the power 3 and 0.9 to the power 5. Okay, 0.9 to the power 3, okay, I multiplied by 0.9, that is 0.9 to the power 4. Okay, and now we go here. Okay, and this is 4 and 2 0.3. Acha, already converged, I think. And so I will check the convergence of this one. Acha, this is the conversion. Again, we will come back here. 0.9 to 3, 0.902, and this is acha, but here is another difference actually. This is 0.9 to the power 2 here. Okay, maximum is 0. Acha, this is 1, and multiplying acha remains the same actually. Will not change, I think.
So all these value remain same.
Remaining same actually. So 0.925 is not the answer?
No, sir.
No?
No. Option is not given.
0.54 as you said. Acha, x1 as you say. X1. X1 is this one. Acha. How much is it?
It is 0.59.
59. 54 is given, huh?
Yeah.
0.9 to the power 4, 5. 159. Conversions. Looks like it is converged.
So I think it will be 0. Vx1.
0.
Yes.
Soon let's start. How 0?
So when it is stable, means at x1 left is -1 or right is 0. If you calculate this, it comes 0.
What, huh?
After stability, when we start from x1, so at x1 the left is -1 and right is the x2. X2 is 0.
X2 0, how? X2 is?
After convergence, the
X2 is 0.9 to the power 4.
So according to this, always it comes out 0.9 to the power 5.
That is what I'm getting. How can it change? Nothing will change here. Everything is stable. I think just 0.959 and 0.54. I got it wrong or something. This is what I feel like. So this, of course, means like here also given as you see, till P convergence does not change for any state. Convergence means the state does not change. Other questions you can do?
Yes. For using one-time application,
4.
So question number 6 and 5, 7. It is already done, but confusion in this till we converge.
Which one? Acha, this one, na? V converges.
So can you explain the 7 how it is become 0?
Means, as they say, after one application of the formula, okay. So as you see, means like if applied the formula only once, okay. So we cannot even actually reach 2x1, okay. That is why it is 0. Left and right, to the right hand state. You've done this one, question number 9.
Yes, sir. I think it's option A and D. C.
See which one will be, okay. And, okay, good luck for your exams. If anybody is okay. Thank you very much.
Okay, sir. Sir, one more problem is there in assignment 11. Assignment 11, question number 2. Sir, I mark option A, B, and D.
A, B, A and B both you can mark. No, both you
Yes.
can mark. No, this is actually a very easy question. What happens is that you have to see the video, okay, and let me show you.
Sir, in this in the lecture.
Lecture only.
But when you see, you don't know how it
Sir
was
mentioned it when the point is coming from a one cluster.
Just wait.
One
Just wait.
Okay.
So what I was saying, not this one, but this one. No, I think I had. So you can see Z and K is the okay. So this is the one Z and K, and that question is